Hello, this is Mr. Huff, and I want to quickly explain the density activity that we're going to wrap up with this Excel file. So when you download the Excel file, go ahead and save it somewhere where you can find it and put your names and stuff in it on the project summary page, which I will speak more about in just a moment. Where you should probably start is looking at the activity summary tab right here, as you can see on the screen. The first two things you will see are links to the density notes that are from Project Lead the Way, and also Engineering Toolbox, which is a clearinghouse of all kinds of engineering reference information, and it may be more than you bargained for. So if you're looking for something specific, you could use the tried and true, let me Google this. If you look at the general instructions, the first thing you're going to do is use each individual data page to record your data and conduct any conversions you need to do, any calculations you need to do, and then summarize your final data with a link into the project summary. If you look here to the right of that, if you click on where it says mass or pound mass, you can look right here and there's a little formula. And what that says is convert, and Excel has a pretty nice little conversion function that will convert things for you. If you don't care to do that, you can use the tried and true math approach. If you know how many pounds are in how many grams, you can do your calculation using good old math. I do expect you to use Excel to do the math calculations automatically using functions and that sort of thing. Okay. When you get to the project summary sheet, you're going to link your data to it, and I have some examples of linked data. If you click on project summary, you can click on where it says the first thing, and you can see here it is linked to data page 1 and it's cell A3. And the way you do this, let's say that I wanted to link some data from here to the activity summary. So I'm going to double click on equals. That's how you have to do it. Equals, click on the page you want, and click on the cell you're looking for, and then when you hit enter, it will pull that information back to the page. So we're gonna not show that, don't want to add that in there. So here we go, this is the summary page, and I expect you to link all of this content in here. Where it says prepared by, put your names, put your class period, put the date that you prepared it. So remember, you can work with a partner on this, or if you're working alone, you'll turn in one for yourself or one for the couple of partners. You're going to report the average weight of one item, the average volume done geometrically, the average density using the geometric method, the average volume if you use a graduated cylinder for the volume and density, and if you use the suspension method, you'll report those. You also need to look up the actual density of the material and provide a link of where you found that information. Google is not permitted. Go to an actual web page and copy the location. If you have information that's not part of that data set, just put NA. Let's say you didn't do this on the first one, so you would put NA and NA. That way I know you at least thought about it. Okay, let's go back to the summary. Once you finish that, there are some questions. Let's go look at the conclusion tab. And I want these 3 questions answered. Compare volumes that were determined using geometry and submersion. Note the differences and explain which you believe to be more accurate. I'm looking for complete sentences in the yellow spaces. Compare the densities to the accepted values for each material. Note and explain any differences. If the numbers are significantly different, you need to provide a reasonable explanation of why they are different. Again, I'm looking for complete sentences in the yellow boxes. You can expand those and they are set up to wrap automatically. Explain how to use density to determine what an unknown material might be, then use your explanation to determine the material of a gray metal sample with a density of 0.258 pounds per cubic inch. Clearly explain how you know. So explain how to do this and then demonstrate that you know how using what you've described. The other pages in this are data pages. They all look exactly the same. I just put a title on each one. Anything you type here will show up in the first page. So if you were doing hex nuts, you could type hex nut right here. And when you go back to project summary, you'll see that it now says hex nut right here. Okay, so that's how those are set up. And what I expect you to do is show me in an area, show me your data you collected. Next to that, show me how you did your conversions. And then finally, report your average weight, your average volume, and your average density on each page. So you'll have one for item 1, one for item 2, one for item 3, 4, 5, and 6. You get the idea. I also have some notes down here about the different items that you're analyzing. And I kind of listed some materials you may see, like steel. On golf balls, you'll have to do some brand research. That's not a industry standard as far as I know. Hot glue is usually ethylene vinyl acetate, EVA. And so you can look at that. There are some other kinds of hot glue out there, but we are using the cheap stuff. Let's just be honest. The wooden blocks are probably yellow pine. Popsicle sticks are usually white or Baltic birch. And the spheres, if they're plastic, they're probably acrylic or Delrin. And then the last thing, the large wooden spheres are birch or maple, and the small wooden spheres are cedar. So look over the instructions, fill in this data table, this Excel workbook, and when you're done, check over your work, make sure you and your partner agree if you're working with a partner, and then turn in this Excel file as your work on Canvas. If you have any questions, be sure and let me know.